Hello people. Today I want to help you learn how to draw ellipses. This is a lab I'm assigning entitled Drawing Ellipses. And the purpose of the lab is to illustrate Kepler's first law of planetary motion. We haven't really discussed this in class yet, but by the time you watch this, I think we will have gone over it. The vocabulary that we're going to be working with today in this lab include the words eccentricity, ellipse, foci or foci, major axis, and minor axis. You're going to need some materials which I'll go through, including some 8.5 by 11 paper, some cardboard that paper can fit on top of, some cotton string that we're going to tie into a loop, push pins that do not go through the cardboard, so you need layers of cardboard, a calculator, and maybe some tape. You might want some tape. The objectives of this lab, again, to draw 4 ellipses on one sheet of paper, to define the major vocabulary words listed above, to calculate the eccentricities of the 4 ellipses, and you haven't learned what eccentricity is yet, but we will, to explain how eccentricity changes as the distance between foci change, to be able to compare these eccentricities, or the eccentricity of those ellipses you've drawn, with those of the planets in our solar system, and to understand the shape of eccentricities ranging from 0 to 1, which again, that's the scale of eccentricity. So let's get on with learning how to draw these ellipses. And I think to do that, we'll pause and we'll be back. So what we have are the tools here that we need. You're going to need a ruler. You're going to need a ruler that has centimeters so that you can do some careful measuring. You're going to need some string. I use string that's not too thick because you're going to need to create a loop of string of a particular size. So you need string, and you're going to need to make a loop of string. I'll show you how to do that. Pencil sharpener might come in handy if you have the old style of pencil. You need push pins, not thumbtacks, but push pins, because we use these to draw the ellipse. I have 3 here, but really you just need to have 2 on hand. Good to have an extra. Then I have a little bit of tape. You can use tape to tape your paper down onto the cardboard that I have here. Now, the paper we're using, I'll get to the cardboard in a moment. The paper we're using is 8.5 by 11, as you can see, and that will work based on the measurements we're going to be using, or the dimensions, I should say. Then finally, again, we have to have some cardboard that we can put the push pins into without the push pins going through to whatever desk you're working on. So you can see I can put this push pin into this cardboard and it doesn't go through the cardboard to the other side. And that's because I have 3 layers of cardboard here that I've cut, and I've cut them a little bit bigger than 8.5 by 11 paper, and I have taped them together at this corner and at this corner, and I could do another 2, but I don't really need it. That's just to keep them together when we are doing the drawing. So you need to have a layer of cardboard, or you could use foam core. Foam core would be good, but something that you will put a push pin in that will not allow the push pin to go through into your desk or be just sticking out. And if you're on a harder surface than the steel, like a stone or some other kind of hard surface, it doesn't slip and slide. That just doesn't work. We are going to now draw some ellipses, and to do that, you need your 8.5 by 11 paper. You need to find the center of that paper. I already have a mark here. I did that by measuring across the 11 and finding 5.5, which is half of 11, and making a mark. It doesn't have to be absolutely in the center, but you know, that we're saying near as you can. And then it's 8.5 across, so 4¼ inches is what I'm using. I'm using inches for this because the paper is in inches. And so I made a mark here. So I have a mark here, which will be the center of the first shape I draw. In order to draw the shapes, I need to have a loop of string that I'm going to loop around push pins. First, it's going to be a single push pin, and that's going to be followed by using 2 push pins together. But I need to make this loop, and to make the loop, I need some string. Now, I've determined from looking at the loop that I have here that a loop of this length, which is approximately 10 centimeters, which I can show you what I mean by that. So the loop tied is approximately 10 centimeters. I've determined that that's a good size because if I imagine a push pin right here where my finger is, I'm going to be swiveling around, and I want to make sure that my string doesn't go over the edge of the paper. So any longer would be problematic. How do I make a loop that is this length? Well, I need to get some string, and I need to cut a piece of string that's long enough so that I have room to make the length I want. And so I'm going to cut a piece of string that's maybe about 25 centimeters. It's probably a little bit longer than I need, but make it more than, say, 24. And cut that, and then you take your 2 ends and you bring them together. Then you wrap the 2 ends around your finger and you make a little loop. Then you take the 2 ends and put them through your loop and draw them through, and then you can assess the length that you need on your next to your ruler. And I see I can pull my knot down a little bit, and I've made a loop that is about 10 centimeters. And that's out of a piece of string that's about 25 centimeters long. So a loop, 10 centimeters. And now I double check that that's going to work by putting my finger in the middle on that spot and just swiveling and making sure that I don't go over the edge. So you need to make these loops of string. 1 loop is sufficient. Obviously, I just have 2, so I said 2. I made it plural. You need to make a loop that you can then use to draw your shapes. Again, we have our paper. We made our loop. I'll use the fresh one. And I'm going to tape my paper down. I'm using some masking tape. And you can see I already have 2 pieces of tape down. I'm going to put a 3rd and a 4th. This just stops the paper from moving as you draw your shapes. And the first shape that we're going to draw is actually not an ellipse, but will be a circle. And we'll base that circle on the center point that we already have marked. We're going to take a push pin and we're going to put it exactly in that center point and push it down nice and solid. And then take our loop and put our pencil in the loop. Draw it tight. You can hold the push pin down with your finger and simply inscribe a beautiful circle. And that's the beginning of our work. So now we have a beautiful circle inscribed on our paper. The second step is to take the ruler and to draw a line that's more or less parallel to the top and bottom edge of the paper. It doesn't have to be exact by any stretch of the imagination. But that looks pretty good. This is just so that we can then use this line for drawing our other ellipses. And this line can go a little bit outside of the circle, but essentially you need what I've drawn here, a horizontal through the center of your circle. Now we're going to make some measurements, and we're going to measure from the center of the circle and make some marks. We're going to measure 2 centimeters, 4 centimeters, 6 centimeters, and 8 centimeters from the center. So I'm going to put my ruler down, and I'm going to make a mark at 2, at 4, at 6, and at 8. So I now have a center, and I have a mark at 2 centimeters from the center, 4 centimeters from the center, 6, and 8. Now I'm going to take my loop again, and I'm going to take that push pin I already used once, put it back in the center, and I'm going to get a second push pin. And I'm going to put this second push pin in the 2 centimeter spot. I'm now going to take my loop, put it over both push pins, not one, but both. I'm going to loop my pencil in, draw it taut, and I'm going to inscribe a circle. And we can already see that our shape is not the same. We don't have the same shape as before. And you see that the string gets a little bit in the way, and I got a little bit sloppy at the end. So I'm going to just erase this part because I think that we've got the right idea here. That 2 lines merge at this back end anyway. So it was a little bit awkward there at the back, but this is our first ellipse. The first shape we drew was a circle, but this is actually an ellipse. This has actually, rather than a diameter, which would be going from here at number 1 to over here, I believe I'm labeling that point A. I'm going to call it that for now. So this would be the original diameter of our first shape, but now we have what's called the major axis of an ellipse, which is going from here at point 2 to A. We're done now with that first elliptical shape. We're now going to go on and do a second elliptical shape, putting our push pin, our second push pin, at 4 centimeters from our center. We're going to pull it taut again, and I can see already that my string has somehow gotten a little bit, it's somehow expanded slightly. I'm going to tighten it up a little bit, pull down that knot. Or I didn't pull it tight enough to begin with. That seems a little bit better. All right. And I'm going to draw my third shape, which is also now an ellipse. And I have that same problem again with going too far out. But I can just erase it because I still have this as a good solid border on my right side. Now I have 2 ellipses. One with a distance between the foci, because that's what the green and red push pins represent, of 2 centimeters, and I have a distance between the foci here of 4. Now I'm going to do a distance between the foci of 6 centimeters. And I probably should have said that earlier. I'm going to try this with the knot away from the pencil. For whatever reason, perhaps my circle was... Oh, you know what? I know what it is. Is that I had, with my circle, my string was right up a little bit above the point of the pencil. So that's what happens. And now the point of the pencil is where the string is. So that's why it's come out a little bit at the bottom. There's my third ellipse, and I'll clean this up here, which you can do too. And that's an ellipse with a distance between the foci of 6 centimeters, and my last will be here. So again, if you can be consistent with where the string is in relation to the point of the pencil, you won't have this trouble that I had at the back here. And this is going to be a very tight little elliptical shape because we can see we don't really have much string to work with. And here's the last shape. Our final ellipse, and we can see that this one is the flattest of all. So we have 4 ellipses. Our 4 ellipses. Now we want to label this drawing. Again, our first shape, the circle, we are going to label at this outer edge on the side furthest from our foci, we're going to label this intersection between the circle and my horizontal line number 1. Then number 2 for this intersection, number 3, number 4, and number 5. And I can get rid of my 2 push pins. Then we're going to label each of the holes made by the push pins, the center of my first shape, the center of a circle, A, my 2 centimeter hole, B, C, D, E, and what I had called A earlier, we're going to call F, this point at the end. And again, this is 2 centimeters, 4 centimeters, 6 centimeters. Oh, sorry, I did that wrong. This here is 2, 4, 6, and 8 centimeters. So this would be our labeled drawing for the moment. And from these labels, we'll be able to then calculate eccentricity of our ellipses. So to do the calculations of eccentricity, what you do is go to the cover of your Earth Science reference table, and then I'd like you to write the formula for that on your drawing. Now, there's not enough room to do the calculations on the drawing, but you can put the formula for it, and you can label this drawing with a title up at the top. So put a title here, make sure your name is on it, and then you can take some colored pencils and you can color in each of the separate shapes. So you can color in a separate color too with a key. So you could color in this middle shape, one color, the second shape, another color, third shape, fourth shape, fifth shape. You should then have 5 colors and a key for each, and you can label them 1, 2, 3, 4, and 5. 5 being your smallest, most eccentric ellipse, 4 being the second most, 3, 2, and 1. Now you might wonder, how do you calculate eccentricity from this drawing? Well, once you have the formula, which is the distance between the foci, so the distance from A to B, or A to C, or A to D, or A to E, divided by the length of what's called the major axis. And for each ellipse, the major axis is the distance first from 5 to F for our most eccentric, from 4 to F, from 3 to F, from 2 to F, and finally from 1 to F. Those are the distances between the foci. So for number 1, the eccentricity would be the distance from 1 to F. So you would measure that in centimeters. And I get 18.5. That's the major axis, 18.5 centimeters. And the distance between the foci, well, there's only one foci for the first shape. So it's 0. And you continue doing that. And you put those calculations into the lab itself. There's a beautiful little box for each one, and you can type them in and do the math. Again, draw these, color these in, name, title, formula for eccentricity, but you don't need to show me the calculations on this page. I'd like to see them in the lab. Now, if you feel like you have room to do that, fine, but a lot of you won't be able to do it neatly, so I'd rather the drawing remain pristine. And with that, I think you have enough information to draw ellipses.